So let's try number 34 out of 11.3 because we need this idea for the catapult anyway. So here I have a picture of some kind of polynomial, and they want me to come up with a possible formula for this. Cool? Mm-hmm. Okay. What do you know right now? Say that again, but think about it first and then say it different.
The equation for the graph is 3. Is it x to it?
It has a degree that is odd.
No, that's what I wanted you to think about. So why do I know the degree isn't odd? Why do I know the degree is
because
even?
it's got 3, so it's probably 4.
Yeah, both ends go the same direction, up or down. So this is even degree.
And positive.
Now, you can notice, right, that there are 1, 2, 3 little troughs, right?
X to the 4th.
You guys all see that?
X to the 4th.
So this is some kind of maybe x to the 4th
Oh,
or
maybe.
higher.
Yeah.
Do you guys see that?
But even.
But at least it's even and it's 4 or bigger.
You have 3x intercepts.
So, hang on. So degree is even, and degree is bigger than or equal to 4. I have 3 of the x-intercepts right now. Cool. So the fact that it's 4th degree, right, means I should be able to write p of x is something, 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 something.
Wait, so
Maybe also some constant, right?
Shouldn't it be plus k?
probably minus k. But that,
Yeah, so these are going to be the x-intercepts, right? So what x-intercepts do I know?
-1, 0, 1.
Okay, so x plus 1 is one of those things.
X minus 1.
X minus 1 is one of those things. And x minus 0 is one of those things.
Minus 0.
Okay, and wait, there's supposed to be 4. No, because they come in complex conjugate pairs. So if there's one complex root, there's 2. So look at this guy right here. See how that just barely tags?
Yeah.
If you shifted this thing just a little bit down or just a little bit up, right?
It would touch 4 times.
It would. So if you shifted it down a little bit, right? It would touch 4 times, and 2 of them would be right here.
Yeah.
If you shifted a little bit up, there would be a complex pair. You guys see that? Because it wouldn't touch. So that thing there is actually repeated twice. You guys see that? If they just barely graze, they're double or at least multiple roots.
Okay. It's kind of the same as if you just had a normal parabola that only touched once.
Yeah. So remember, right, the x squared should have 2 things. Right? It should have 2 roots. But it only has 1 at 0. If you shift it up a little bit, it gets no roots. If you shift it down a little bit, it gets 2 that are really close to 0.
Is this one of those things mathematicians just say is correct so it matches their theorems?
No.
'Cause I know that happens sometimes.
No. This is one of those things that I can demonstrate to you has to be true from Calc 1.
Or just picture.
For you guys, I can say that that spot is flat, right? So that tangent line there is horizontal, which means the slope is 0, which means if I take a derivative, that x minus 1 thing has to appear in there again. The reason it appears in there again is that there's 2 of them in the formula. Cool?
Just so you know, that's the only reason why 1 isn't a prime number. Because if it was, it would screw up a huge thing.
No, it would just make the next. Yeah. Okay. Sure. There are some things that are made for semantic reasons. This is not a semantic reason. This is a math reason. You push it down a little bit, right? There will be 2 roots that are really close to 1. You guys cool with that?
Yep.
Okay, so I got this. Now I know everything about my polynomial except k, right? So how could I possibly find k?
Y intercept.
Which
No.
is 0. Oh,
I know the y-intercept is 0. Right?
They give you that problem, that graph.
But
right?
if I plug 0 in here for x, right? I get 0 out anyway. I already fixed that. See that? That was me saying this intercept happened at 0. So
They give you that point right there,
yeah, they give me another point, right?
but it's not the vertex.
It's not the vertex, but at least it's another point, which is a, yeah, a point on the graph, right, is an x comma f of x pair, right? Or p of x in this case. So I know that if I plug minus a half into there, I should get minus 27 over k, or over 16.
So then you just
So I can say minus 27 over 16 has to equal
negative 1/2 plus
negative 1/2 plugged into this crap. So I get, let's see, negative 1/2 plus 1 is 1/2. Negative 1/2 minus 1 is negative 3/2.
and then
Negative a half, and negative 3/2 again. And that constant k, right?
so
Okay, so
Just multiply the two.
let me just simplify a little bit. So I got minus 27 over 16 has to equal, on the bottom there I got a bunch of 2's, which make, when you multiply them together, 16. There's 4 of them.
Yeah.
Crazy. On the top there's, let's see, minus 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 makes a minus and 9k. Okay, so algebra will tell you k is 3. So then you can go back and replace your proposed equation with chemistry. And now I've actually pegged down all of this thing, and I didn't need to know the vertex, right? I just needed to know something.
yeah, it just needed to work.
Yeah, so what I have here, by the way, is only one possible solution. You guys see that? I haven't dealt with the degree is bigger than 4Ks because those ones I definitely would have some trouble with. You guys cool with that? So this is the best I can do for right now. Cool? Questions, Steele?
So can you show us why that shape occurred?
This whole shape?
Yeah,
Yeah, kinda.
because I don't know why that shape would ever arise.
Oh, like a. So wait, do you mean like an application in which this shape would arise, or do you want me to get this shape out of the map?
Get that shape out of the graph.
Okay. So out of this set of math, right, out of this formula for my function, I would say, okay, so I have, here is 0 at negative 1, so I'm just going to dump this picture and I'll recreate it. Okay, so I have a 0 at negative 1. Boom. I have a 0 at 0. Boom. And then I have a double 0 at, oops, positive 1. Boom. Okay, the double 0 is going to make something that just barely grazes. I don't know whether it's up here or down there, but it's going to make one of those. These guys aren't a double 0, so they're going to go straight through. So they're going to look like either this or that, and either this or that. Cool. If I multiply all this crap out, I can tell you at least that I'll get a 3x to the 4th plus some crap. You guys see that? And then also at the end, I'm going to get plus some x's. Right? And then constant term?
3, 3.
Why is there no constant here?
Because it's at zero,
It
zero.
passes through zero, zero.
Because there's a freaking x here.
Freaking
You guys see that? So if I multiply this through, right, I'm going to get some x's. Like every term's going to have some x's in it. So I'm going to get a plus 0, which really tells me the y-intercept, right? But I already knew the y-intercept. Okay, so then the fact that it's 4th degree tells me that if I zoom way out, right, it's going to look like either this or that. And this thing's positive, which tells me if I zoom way out, it's going to look like this.
Yep.
Cool. So I know the tails go up, up. Okay, I know it just barely tags 0 here. It can't go this way and then back up without having another 0. So I can dump that option.
Yeah.
So that tells me I can connect this to that.
Okay.
And then here, it's got to be above 0 for a while. If I kind of trace that back, it's got to go through 0 here. So that's got to look like that. Can't look like the other one, because it would have to go through the other way. And then in here, I'm now below 0. And I have to end up going up there, so I've got to cross through from the bottom up.
Yeah.
So I get this. I don't know the heights
Okay.
when I do this process. Like, I don't know whether
Extreme
this
is the
bump's bigger or smaller than the other one, and I'm not going to.
Okay.
I could figure it out by pegging a couple of points. I could say, okay, this is like 0 and 1, so this bump is like maybe about a half. It's not actually at a half because I don't have any symmetry to exploit,
Yeah.
but it's about a half. So I could take a half, plug it in, get some height. I still don't know which side of the bump it's on, but I could at least peg a height for a half.
Yeah.
And then I could do the same thing for minus a half.
Yeah.
You guys kind of see that? There's better tools for this.
Yeah.
Like when we do Calc 1, we'll have one of these ways to add diagrams together. Remember I showed you that diagram of concavity and like smiley faces and stuff?
Yeah.
We'll get some more of that, and we could see that here, right? This is made out of half of a up smiley, some up smiley, some down smiley, some down smiley, and some up smiley. Oops, and there's actually a switch from a down to an up there. You guys cool with this? That would take a while.
Yeah.
Like that would be most of 30 minutes to do on the board. Cool?
Cool.
The double roots making the little tags is a nice trick to know.
How's this related to the catapult?
How's this related to what?
The catapult.
Oh, good. So this is related to the catapult because we got 3 points and we know it's a parabola, so we should be able to find the equation. So let's do that.